better. Okay, well, I'm hoping everybody can see me. If there is anybody out there and you can see me, then put it on the Slack channel, just let me know. And if not, I'm going to go for it and we'll assume it's working. Okay, great. Thank you for confirming it's working. Okay, so I'm Wyld. I'm CTO of a company called WT Consulting in France. And I also act as CTO for a company called Infophone in Germany, a startup. And it's in that context that I'm going to talk to you today about the question of using MicroPython on embedded devices. And specifically, is it ready for the real world? Well, that's the question. A bit about me, just why I think I might know anything about it. I have an MEng from here at Wyld University in Scotland, and I've worked for maybe the last 30 years doing telecoms, network, equipment, software, everything from 6502s to start with via ARM, on 86 and PA-RISC, in everything from assembler to Java, on all the different boxes, embedded systems and Unixes, and even on Windows. The latest thing was even on the AWS's serverless using JavaScript. So I've done quite a lot of embedded programming, a lot of systems, a lot of backends. And in that context, that's why I'm working as CTO for these companies. Done a lot of different products, not just playing with it. So the question first that maybe we should ask is, why would you want to run MicroPython as an embedded system? Basically, the last 5 years working for a company called Wyld, we were doing devices for indoor geoloc, and there the development environment running on an STM32. It was in C, on bare metal, or with a minimal RTOS, minute in this case, and the pain involved in the development and debug side of that. You know, there's tools and so on, but there's quite a lot of pain involved in that kind of development, and therefore I was looking for something where basically I could insulate the application logic from the operation of the system on the device. Something where I was hoping that by going to an interpreted model, I would end up with more resilience when the application logic crashes. The idea being that as the application logic is a bit evolves rapidly, you want to be able to update that as and when, perhaps from third parties, but you don't want to crash your whole device and brick it. I'm looking for some high-level support for things like JSON processing, MQTT, and so on, directly in the device, rather than having to use libraries at the C level, and have something a bit simpler for the development. Avoid the issues you get with your ARM tool chain of different updates break it, different versions aren't compatible with different other tools. You know, had a lot of pain dealing with that kind of problem, and I was looking for something where that would all be nice and easy and everything would just work and it's all interpreted and all go nicely. And finally, where we could integrate easily into a continuous integration, continuous deployment type chain, to be able to run unit tests and stuff like that every time people check in code, rather than having the whole cross-compilation issues when you're developing for ARM, but your backend, GitLab or whatever, is obviously running on Linux. And of course, MicroPython, very trendy now. Hadn't had a chance to play with it, so that was a good reason to do anything. You may not be nothing to do with that one, of course. So basically, the last 4 months since January, I've been intensively ramping up on Python/MicroPython. We've been developing a device, I can't really see, but a little handheld widget with some e-paper device and touch screen device, based on an ESP32, running the PyCon module. So we're running MicroPython as our development environment. And we wanted to create something where a generic device can be the base platform for different projects. Therefore, people can build their own applications and integrate them into the system. And therefore, we want something where this can be quite all these different applications from other people can be isolated. If one of them has bugs, it doesn't affect the others. We don't crash and hang and have this device in the hand of people who are the general public who don't know what to do when it doesn't respond anymore. And our initial functionality is to have something that displays basically information coming from a data viewer, data entry type systems, basically around digitalization of workflows in hospitals, train stations, airports, that sort of thing. There's a lot of JSON and MQTT exchanges with the back end to integrate with applications. So I wanted an environment where we had ease of processing of that kind of data. But equally, we have a UI, so we have people pressing buttons and they expect a good reactivity. So we need something that's also got that multi-threading, good reactivity, because we're running a UI for people. And the MicroPython promises from generally and from PyCon is to have an easy to develop environment, easy to debug, good functionality straight out of the box, good high-level APIs. That's what we do for the last 4 months. The question is, what happened? But definitely drunk a lot of coffee. The first issue I had with doing a development project running on MicroPython is to find developers to work on the project. I'd actually had some Python experience with students working on stage, working on internships in companies I'd worked for, but for doing scripts. And Python is is a very popular language. According to my last Google, it's the 3rd most popular language. It's got 30 years that it existed for, so there must be a lot of experienced people out there running it. But the issue I found was that you put Python experience on a job ad, you're going to get a lot of people, but it's not the same as I'm looking for somebody to do embedded work in MicroPython for a product. There are a lot of people with a lot of Python experience, but they're not all at the same level. It's kind of the same, I think, had experience with the looking for C programmer, but if you're looking for an embedded C programmer to run on an RTOS, it's not the same experience, it's not the same skill set as when you're looking for a C programmer in general. But this was like much, much more. I found there's a lot of Python experienced people, but you obviously have the people who look at the video on YouTube before coming to the interview. So not really ready for prime time. I've got my hierarchy as we go down. People get more and more real experience in the language, but to find the guy at the bottom of my pyramid who is the Superman or Superwoman who can actually code competently in MicroPython on an embedded environment where you're doing a real project, you're not just doing a script or a POC. It's for a real product, it's got to be shipped out in the thousands or tens of thousands. Those are difficult to find. So that's your first issue using MicroPython, is finding somebody who's actually competent, who's actually got the experience you want if you're looking for an experienced developer, or even finding training to get somebody up to speed on that. So you've got to be prepared to spend time, I found, in training and learning, and including learning how to code it up and then find that's not the way it should be done and having to rework. And that was my experience coming to MicroPython as well. Second challenge I found with MicroPython is that it's 30 years old, so Python in general. So when you say to somebody, can you code in Python? You've got to be careful about which MicroPython you're talking about. Not everything that looks like a Python developer is a MicroPython PyCon developer. Everything that looks like a dog, maybe a dog on the internet anyway. And there's significant changes between Python 2 to Python 3, even between Python 3.5 and 3.9. The language has evolved significantly, which is important because MicroPython basically is a fork to run on embedded systems roughly based on 3.5. So you may have people who have recent experience up to date on Python, but some of their instincts on programming will be from the Python 3.9, and those things just aren't supported on 3.5, or even might be supported on 3.5, but it won't work on MicroPython. So MicroPython has some significant differences from Python in some of the libraries, some of the tools you can use. And even between MicroPython, there's MicroPython for PyBoard, and then there's PyCon, who have their own version, and it's not quite identical. There are some calls that are different. PyCon have made a lot of effort putting in work on some of the libraries that are then specific to them. So when you're looking for information, looking for training, looking for people who are competent in what you're doing, then again, somebody may be right up to speed on Python, but not have any experience on MicroPython and get caught out by that. So every time you're trying to code something or work out how to do it, you don't just look for Python, you've got to look for Python first, and then, okay, maybe it's MicroPython, or maybe it's Python 3.5. The word, I'm looking for somebody help on Python, isn't a useful sentence in this context, I found. And therefore I was not aware of that when I started, and very rapidly fell into the traps of getting stuck with, trying to do something, spend a day working out why it doesn't work, and it's because it's not supported in that version of Python or not version of MicroPython, or works differently on the Python board. And what I found is we need to get tools that can take that into account. Luckily, some of the tools can do that, but MicroPython, it's not there yet. So if you're going to go down the MicroPython road, make sure that you have worked out what your actual MicroPython environment is. There's the whole thing about Python's an interpreted language, and there are some big advantages to that. And one of the big advantages I wanted to that was the ability to do over-the-air updates as partial updates. So I don't need to rebuild my X megabyte image and re-download it all. I don't even have to do a delta update of a fully linked image, because my Python files are compiled and interpreted at runtime. So that's a big advantage when you're trying to update your code. You don't need to worry about all the rest of it and linking it all together and having an enormous binary to download. You can download just the MicroPython file that you bug fixed. But of course, not having a compilation phase means that you discover a lot of stupid bugs at runtime. And I've discovered a lot of stupid bugs in my code when I actually run the code. And that makes your development cycle much longer, because you code it, you think it looks okay, you download it, you run through your test case, you get to your test case, it falls over, you have to then work out why. Oh, it was because I had a stupid typo. Even if you lint, even if you syntax check, then your stupid typos, because Python is weakly typed, can mean that your variable that you thought you had, it didn't mind about you having a misspelled variable name, because you might be making it up as you go along. When you get to the actual execution, then it goes, oh no, sorry, that guy doesn't exist. Or what you thought was an int was a string, and that's okay in some cases and not okay in other cases. So you run into a lot of problems around this weakly typing language issue, which makes it very difficult to look at a piece of code and say, is it going to work? Is it even syntactically correct before I run it? There's a whole aspect of the load and import subtleties which I was not really up to speed on, having come from the compiled language background, where you end up with your import that actually runs your file to create the definitions, but then if you then import another file that recursively imports it, there seem to be some things that in Python you just can't fix nicely, and you have to end up doing some tricks to get out of these issues, and they're all to do with the fact that it's an interpreted language. And there are some solutions. There's a lot of stuff in Python now about forcing typing. So effectively, you're reverting to a strongly typed language. And that's quite interesting to do. That allows you to make sure that it's part of the documentation of your system. And there are tools like Pylint and MyPy in particular, which will allow you to both check the syntax, but also check typing. Am I passing a string to this parameter? Is it supposed to be a string? I'm expecting return from this function, which is a Boolean. Is it actually a Boolean? And therefore, there are these tools that will allow you to check in a continuous integration step, is my code good before I go and run it? Again, we run into issues because some of these tools, they need stubs for the libraries, and some of those stubs and some of those checks, the difference between Python versions and Python and MicroPython are not necessarily taken into account. And finding the right stubs, finding the right sets of checks that will allow you to check and not have false errors just because your version of MicroPython is different from Python 3.5, for example. Some of these tools aren't quite there yet. And the other aspect of this whole interpreted language thing is it's bad for your memory. And when you've got your memory on your embedded system, of course, I'm talking about embedded systems. It's not like running an embedded Linux. We're not running basically an embedded server. I'm talking about, the systems we were running before. It's an STM32. It's got 32K of RAM. It's got like a mega flash if you're lucky. I would say you're not going to run any kind of reasonable sized micropython system on that. The interpretation gives you this memory allocation issue, memory size issue. It's almost impossible to know when you allocate, and you don't even know when you're allocating it's interpreted, wherever the heap, it has got sufficient memory for the size of the block you want. You end up in my code, you do your treatment of a message, and everywhere you're doing GC collect in order to force the garbage collector to collect all the little objects you're creating as you go along in the heap, which are causing you to end up with your heap being fragmented. And then it wants a K of memory, which shouldn't be very much, and you find it's so cut up, so fragmented, it can't even manage to GC. And of course, in an embedded environment, that's really quite difficult because you don't know whether your code is going to run and whether it's going to keep running. The other problem with the RAM, but which is manageable, is that phase of I load .py file, it gets pre-compiled to bytecode, and then I run the bytecode. That can take up a lot of RAM. You're not going to do that in 32K. On our ESP32, we have 4 meg, and we need the 4 meg of RAM. Now, there are ways to get around this, and indeed pre-compiling, you see somebody asked about that, is that indeed on MicroPython we can have this pre-compilation phase where we pre-compile directly to the bytecode, and that reduces both the size of the files, so less space in RAM, less space in flash, and means that you don't have the RAM used by the compiler. So that's essential to do if you're running RAM problems, and it also makes the startup a lot quicker because it's not doing this phase. The issue is on MicroPython, in Python you can precompile. MicroPython has a specific MicroPython recompiler, and PyCom has patches for the MicroPython cross compiler in order to make cross-compiled bytecode that will work on PyCom. So again, you've got to know which version of Python MicroPython you're going to be running, because to make sure that your tool is patched enough to get it, which is of course one of the things I was trying to get away from, trying to have tools that would not have these dependencies. There's also the possibility to freeze the bytecode, to say, okay, put it into Flash and execute it from the Flash, which again will save you RAM. So there are ways around the interpreted language issue in terms of RAM size for that. But for the memory allocation of the heap, it's a problem with any language that uses a garbage collector. That at some point you can get too much fragmentation. But my experience was that MicroPython is very prone to that. And if you don't run GC collect regularly, then your thing will be gone. There is this issue as well that you can't pre-allocate everything that you would allocate on the heap, as you could in C, for example. You can't have pools, and that way you can't predetermine that your heap will never run out of size. You can't be sure of that. Obviously, I have not managed to be sure of that. Multi-threading, yes. Obviously, I'm looking for something with multi-threading because I want to have this responsiveness on my UI while it's also communicating the network, while it's also dealing with the hardware sensors. I mean, all you can say about multi-threading in general, of course, is it's complicated. And that's even before you start, because Python has multi-threading now in the latest 3.9 based upon a JavaScript type, I think a weight type model, which is kind of cool, even if it does do my head in. But MicroPython does not have that really. It has some async IO partially supported, which I will admit I haven't gone into a lot of detail, and a lot of the libraries in MicroPython don't yet support that. What it has is a _thread library, which is different between MicroPython and PyCom's version of that. Not everything is the same, not the same support, and it's pretty basic. And what I found is, that's what I was using to do my multi-threading, and I rapidly ran into issues with stack size, and you try to change the stack size and discover that stack sizes are limited by the underlying port. which means that you can't change the stack size to avoid running out of memory just when you've got, like, maybe 10 function called deep calls and you've got a stack overflow. And where you get into that is, this is the multi-threading, there is stuff that works, but it's pretty unclear what will block, what won't block, what stack sizes are. There's not a lot of good documentation, I have to say. And you have this thing in Python with the global interpreter lock on the threads, which means even when you are multi-threading and it's working, if you're calling some of the API libraries, you don't know if your port has a global lock somewhere in the interpreter, and whether that will mean that, in fact, what you thought was going to be multi-threaded and nicely divvied up is actually going to not just end up all serialized due to this global interpreter lock. And again, finding information about, does your port use that? How much? What's the chunk size on these locks? Is very difficult to find the information. So basically, you come back to even more than I would usually embedded. I try to avoid having multitasking, multi-threading. Basically, I find that you need it for the I/O, and async I/O does give you some steps towards that. And everything else, you want to serialize your operations anyway to avoid deadlocks, race conditions, etc., all the horrid stuff you get with multitasking. Nearly done. So we're talking about performance. And again, when you talk about performance in Python, people kind of go, well, it's my script. I'm just running my script. Even if I'm running my web application, it's my server has got your umpteen cores, gigahertz speed, and as much memory as you can throw away. When you're an embedded system, then you're not working in that system, and interpreting bytecode is definitely a cost compared to native code, and it's quite difficult to find any good information. Well, I found it difficult to find information about the relative performance, even of different ways of coding in Python, different ways you can iterate, different ways you can do an operation. It's quite difficult to find anybody that can say, well, this one is higher performance than doing it this way. Pre-course compilation helps you for the startup time, but not the execution time. What saves, I think, and allows you to use it even for quite compute-intensive cases is the fact that you can quite easily integrate a C library into Python. And a lot of the libraries and the APIs in Python, MicroPython, are in fact C libraries, and that allows you to say, okay, I can always recode my block of Python that's taking up too much time as a C library, test it so it's really solid, and then just put a Python API in it and continue to call it from application, and that lets you get out of this problem of the Python execution is not speedy. There's also, as I said, this. When you precompile to bytecode, there's also some cases where you should be able to precompile to native machine code, but I have to say I haven't tried that yet, and whether that is stable or not, I can't say. And finally, the thing I found most difficult which is linked to the problem of finding good MicroPython developers, is that when it gets hairy, when you start with your multi-threading and your stack size and how to change it and all it core dumps and it asserts, finding a real expert to help you is quite difficult. There are forums and facts and docs that you can go through. There are issues about, somebody responded to a question about it in 2018. 2021, that response may not be up to date because things have evolved since then. And what I find is the only way to get a real response is to find some way to get support from, if you like, the people who did your port to your hardware. That's a MicroPython element, in my case, Python. And even if you have to pay for it, then obviously it will save you a lot of time if you get stuck. And that's when you're doing a real product and not just a hack or a POC where okay, it doesn't work, we'll look at it later. When you're trying to get a product out to the market, then time is money. Better to pay someone to get you out of the hole you're in immediately than to spend a month having to go back to the original Python sources for the port to then work out why your thing isn't working the way you thought it should work. You need to get good support because it's not as there's not as much information around on the internet as for certain other languages, and particularly for the micropython in a product in an embedded environment case. What can I conclude from all that, since we're at the end of the time? Well, from my point of view, the positives do help in my specific case, where I've got this multi-application. I want to have applications running from third parties. So building with the tool chain is, my opinion, still much simpler than your embedded C ARM tool chains to do with the updates and the bugs and the incompatibilities, even with some of the issues around the cross compilation. Debugging is still easier. It's I used to work with C, and you were into the debugger all the time to find out what your code was breaking, and even C++. When you go to Java, and pretty much you eliminate the no pointer scribbling over the memory, and it goes off into the weeds. When it's just you follow the exception, call trace stack, and say, okay, I see what I did there, then it's much easier to debug. And Python is in that case where it breaks. You've got to be up to speed on Python to know why it broke, but on the other hand, you're following the exception and not, it's just gone and hung and I don't know what's happening. And the data processing operations are much more succinct and much more stable because you're not coding them yourselves or using a third-party library. But you've got to be ready for the challenges. And if you're aware of them, unlike me, before you start, then you can take time to set up your development environment, ensure you've already got your mypypylint code checking. When you code, you're immediately coding to a good coding standard. You're immediately getting the lint in, you've immediately got the type checking, and that way you save a lot of wasted time. The tool situation still needs to improve, in particular for the MicroPython stubs and support for variants like PyCom, in order to avoid having Pylint telling you something is a problem when it's not actually a problem in your environment. But it's a step in the right direction, and if you get it set up before you start, you will save a lot of time that I wasted running around trying to work out why my stuff didn't work. And if you do that, then you can also have your cross compilation, so you're already managing your performance and memory issues right from the start. Is that on there? Yes, I think it is a reasonable choice in certain cases where you want the advantages it brings, but you should be prepared when you start to deal with these challenges, and that way you will avoid, like I did, spending time working through them. Any questions? I think questions will be on the Slack. Okay. No questions. Excellent. Okay. Yes, so I actually responded to a question from Christopher that it does have the cross compilation stage, but again, make sure you've got the cross compiler that is correct for your MicroPython. Anybody else? If not, thank you very much for listening. And the slides, I guess, will be available at some point somewhere. If you have any other questions, then feel free to find me on LinkedIn and let me know. Always willing to share experiences about what we've been through, because that's the way, I was frustrated by lack of information when I started. So, if you're thinking about it, don't hesitate to get in touch and drop me a question, and always happy to share. Okay, thank you very much, and enjoy the rest of the conference.